Welcome to the Meltzone podcast from February 23rd, 2019. I'm Tom.
And I'm Stefan. And on today's episode, we are talking about the current projects we are working on, which go in line with nasty fumes from SLA printers and some projects we are doing with our resin printers at our shop. Then we have a really news-packed episode this week, which is covering the drama around the Nozzle X, and on other news regarding E3D, their new slicer Pathio.
Yeah, we also have some more drama about Artillery 3D stealing FilamentFrenzy's photos and using them for their own marketing. We talk about the Prusa newly released Mark III's and MMU 2S. Well, more about the Mark III's than the MMU. And yeah, a bit more of a rant about Article 13. I'm sure you all are super interested in that because it's going to affect all of you, us two in particular, but also all of you who are watching and listening. For the topic of the week, we talk about 3D scanning, the methods that there are available to you, what they're best used for. And, as a quick outro, we follow up with the printing on copper clad board and making PCBs like that. All right, Stefan, how are you doing?
I'm doing fine, Tom. How are you doing?
I'm doing better. And that actually leads us into topic number one. I'm feeling fine now. I've not felt this good in a while, and I blame SLA fumes. What a start to the episode. So, yeah, projects. My project the last few days, I guess, was putting in a ventilation unit into my basement studio. It's a small room, like 20 square meters or something, and it's completely enclosed. There's no fresh air circulating through. And like the last few months of 2018, I went down there, I felt like my throat was getting achy and my nose was tensing up, and I just, And then I tried one thing. I took the One-How Duplicator 7, an SLA 3D printer, took it outside into the shed, and after a week or so after the studio got some fresh air, it was all better. Like, I can now breathe down there. So now I have a ventilation unit in there that's constantly circulating heat and recovering heat and moisture, because I don't want to be pumping in moisture into a studio where you're printing with filament. So that's in there. That's fine. And I still blame SLA fumes for this. I need to get like an allergy test or something. I still need to find someone who does that with resins.
Mm-hmm. Did you just like drill a hole into one of your windows, or how did you?
I was thinking about the window, but we do have like an outside door, like a steel door, and I actually 3D printed some inserts that are like doors like 2 inches thick or something, so 50 millimeters. I printed some inserts that have like a grill on the outside and then plop through the door, and then you have a printed thread on the inside, and it just clamps onto the door. Works perfectly. So that has some hoses on the inside, and that's working well.
That's pretty cool. Is it? Do you do the energy recovery with like a heat exchanger on the inside? So like the cold air comes from the outside and is getting warmed by the warm air that is going to the outside.
Yeah,
that's pretty.
So
cool.
It's not a DIY build. It's like a readily available unit. It's Senda Comfo Spot 50. So a really small unit that you typically drill a 30 centimeter hole into the outside wall and just plop it in there. And typically you have like the, what's it called on your car when you cool your charged air? Ladeluftkühler, whatever. It's not just an aluminum heat exchanger. It's actually like a salt-loaded polymer matrix, something that also allows moisture to penetrate or to creep through. So that basically the absolute humidity of the air coming in and out stays the same.
Mm-hmm. Yeah, that's a pretty common thing in new houses nowadays, that you don't like get fresh air into your into your apartment by just opening the door, but this is constantly doing that, and it's wasting way less energy.
I think it's mandatory even to have some sort of energy recovery ventilation or heat recovery ventilation unit in new buildings.
Yeah.
So yeah, those are becoming available, and I've thought about putting some or something like that into this apartment as well. just for energy efficiency and all that, especially in winter and summer, where the temperature difference between inside and outside is so high.
Yeah. But that's pretty cool. But yeah, SLA fumes. I also have 2 SLA printers right here, and always when I'm printing, I don't really like it. It's always
Yeah.
smelling. Yeah, you can have an enclosure around it that directly ventilates outside, but also for resin printing, the temperature is kind of a factor, so you don't want it to be like cooled all the time that way. And usually the lamp, which is on the inside, helps for getting like a raised temperature in comparison to the outside environment. But yeah, it's always smelly. I noticed that with more expensive filaments, it's not that bad anymore, but still
With the resins?
with the resins, yeah.
Yeah. I mean that they make, or some companies make full enclosures with like activated carbon filters and HEPA filters, like matched together that supposedly take out all those particles. But yeah, I mean, if you guys listening don't know what the issue with SLA is, and with the resins in general, this also applies to like epoxy resins. The thing is, you're fine if you get it on your skin, or if you get it, if you breathe the vapors, you're fine for a while until your body, your immune system gets sensitized to it, and after that it's just hell. As if you get past that point where your body reacts to them, you basically can't work with those anymore. You can't be in the same room when somebody's using epoxy resin. If you touch the thing, you get hives and immune system reactions. It can be downright threatening if you get your body to that point. So even though, if you're working with SLA resins or with any other resins, epoxy, those sort of things, just be careful. Just because you're fine now doesn't mean that you're going to be fine forever. Use gloves. I always cringe when I see people just smearing epoxy resin around with their fingers, because that is the exact thing that is going to get your immune system wrecked. Yeah, be careful, folks.
That's pretty interesting because, well, you probably haven't been working that much with SLA so far compared to other people who run like many printers at the same time. But I guess it not the amount of material is the thing. Just some people are more sensible, so even though they only work with small amounts, their body reacts faster, just like with hay fever and things like that.
I mean, I've been working with epoxy resins, just the 5-minute epoxy for forever, basically, as a hobby adhesive. And I mean, I gotta say, I've not always been as careful as I should have been with those. So I might be kind of predisposition, that a word, with from that. But also just the fact that the printer has been in the studio, just always in there, and I've been there for hours at a time, and basically daily breathing in that air that maybe had whatever fumes that resin is giving off just accumulating there, because it didn't have any real airflow. So yeah.
Well, it's nice that you figured that out. But speaking of SLA, I'm also currently, well, I haven't been doing much with SLA so far, but I'm always asking myself, what is the potential of SLA printing? And one thing is like the strength of the parts you can print with that. Is SLA only for like, a decorative pieces, or can you even use it for printing functional parts? And the thing is that the technology gives you the ability to print really, really finely detailed structures. And if they would also be strong, that would be pretty nice. And there is, just like with FDM 3D printing, a large variety of different resins you can purchase. So I'm currently thinking about like doing the test I do with my filaments also for some SLA resins or some MDLP resins, just to see how they perform. Because I'm really interested in that. Are there some applications where it does make sense to use 3D printed parts?
I mean, the nice thing is you have no layer lines, right? You have like one solid part that is, the strength and rigidity is very even throughout the part. Doesn't matter which direction you look at it.
Yeah.
By nature, you also have 100% infill on everything. unless you model it into your part and you have little drain holes. But yeah, that's very nice. I'm still expecting that SLA, if you actually do test it with, for example, that hook you have, I expect it to be pretty brittle, to not give a lot before it breaks. So that's going to be interesting.
I have so I before I just have been printing with the normal resins that you use for decorative parts. I have one bottle of, I think it's PO Poly tough resin. So they are claiming that this is an engineering grade material that you can use for mechanical applications. So I'm quite interested to take a look at that, and I think also like the viewers would be really interested to know how it compares, because there are many rumors around, but no real tests that I have seen so far besides data sheets.
Yeah, SLA is still this quite new approach, and I think it's always going to be like not a mainstream technology like FDM, because I mean 3D printing is so popular because you can do it everywhere. It's kind of clean. It doesn't make a lot of noise. It doesn't have really nasty fumes. I mean, you can smell the PLA, but it's not that bad. And SLA, my experience with SLA is always that it's just such a huge mess and such a pain to print it. You always end up with like resin everywhere, and you need to make sure that you're not like lifting the lid in the wrong moment, that sort of thing. Form labs apparently have solved that pretty well, where you never really get in contact with resin. But yeah, what machine are you printing on?
I have the DAS 3D L120. Which has been a Kickstarter machine, and I don't know if they have already delivered all of their Kickstarter backings, but this is the only real proper machine I currently have at home.
Right, so that's an LCD.
It's an LCD based 3D printer. I have never been working with a real SLA printer. Well, I have to say we have a Formlabs printer at work, but it's still in its packing just because we currently don't have any space to put it. But hopefully in the next couple of weeks, I'll also get to use this one. And it will be really nice to see the comparison of a Formlabs printer where you have this enclosed system, you have the washing station and all of that, compared to the more like hobby machines people currently having.
Yeah, I mean that usability thing I think is the big differentiator between the machines right now. Of course, Formlabs also tout that they're an actual real SLA printer that works with a laser, as opposed to an LCD or a projector, a DLP system. Yeah, I guess in the end, at the resolutions that you're getting, it doesn't really matter that much which technology you're using, but well,
everyone has his or her preferences. But maybe staying with SLA, Prusa has just been releasing a blog post where they talked about when their SL1 will be shipping, and also the upgrades to the Prusa Mark III and the MMU2.
Yeah, so the Mark IIIs and the MMU2s, which is going to make it, just like with the Mark II, really hard to talk about whether you're talking about more than one Mark III or a single improved Mark III, because they're both like Mark IIIs.
Yeah.
I think, but is it Mark IIIs or McCass? Is that a 3 or an E?
Don't start with that. Otherwise, we're going to end up in the Slick 3R slicer discussion once again. You probably also have been taking a look at the changes, and I think the changes are, I don't know if it's minor or if it's a really interesting thing. So basically, for the Mark IIIs and the Mark 2.5s, they have been changing their filament runout sensor again. So before they had been using this optical sensor, which supposedly didn't work perfectly for all filaments. People were unhappy with it, and they switched back to a mechanical system.
Yeah. I mean, I've seen some filaments where it just doesn't work well, and that is just the nature of the beast. They've done some major improvements with the new firmwares where the printer is actually going to tell you, hey, I'm recognizing that this might not work as well with the filament you're trying to load. Would you like to disable the sensor? I think the optical sensor, nice idea. It's good that it's in there, and when it works really well. It's just that I don't think mine has ever triggered for like a film install. With the Bondtech drives in there and a good hot end, I just don't get any clogs unless you have dusty filament or whatever. So that active checking whether the filament is still being fed, maybe not that necessary. Yeah,
But that's probably not working anymore. So now they just have a filament runout detection, but no filament jam detection. I can't really remember if I ever had a filament jam that was recognized by my Mark 2.5. So yeah, with the Bondtech gears, as you just said, it's usually not that big of an issue, but that's kind of crosses out one of the features of the Mark II, and, which is kind of sad, but yeah, well, it doesn't happen that often.
Yeah, I mean, I think that the feature of having just filament runout detection where your spool is actually over and there's no more filament left on it, I think that's much more useful because now it allows you, or that still allows you to use up those last bits of filament on a spool where you have 20, 30 grams left and it's like, I can't really print anything with it because I don't know if it's going to be enough. So with any sort of sensor, I mean, these sensors aren't expensive. You can get them for like $1 or something off AliExpress. And just connect them to a spare GPIO on your board. It does do that. It checks whether there's still filament present, and if not, Marlin is going to say, hey, maybe give me some fresh filament, and I'm going to keep on printing.
Do you know what are the major changes with the MMU2 or MMU2S?
I've tried looking it up. I think it's just small incremental bits, reliability stuff. Gotta say, I don't really know what the MME2S changes are, but I do know one more change of the Mark III's, and it still has to do with the toolhead. So previously they've made that improvement where your cooling fan got a redesign and the fan wasn't vertical, it got slanted to 45 degrees, and now that entire thing, the hot and cooling as well looks different, and it has like Venturi air channels or whatever, which apparently don't do a lot. But
well, the Venturi channels already were there with my normal 2.5 for at least for the cooling of the cold side of the hot end.
Okay.
Yeah. So, but I have also seen some pictures on Twitter or something like that, where people were talking about that those Venturi slots don't really help that much.
Yeah, I've seen some GIFs where people took like a blown out candle and demonstrated that there's not really being any air being sucked into that slot. So yeah, and that entire release of the Mark III's and MMU2S was pretty stealthy. Like there was no announcement, and people all of a sudden were getting the Mark III's versions and MMU2S versions shipped instead of the Mark III they ordered.
Yeah.
So I guess good launch on that. Not such a great launch on the SL1 that still hasn't shipped.
But they have a date for it?
Yeah, so end of March is now the final date that they expect to ship, but like the original shipping date was mid-March 2018. Mid-December 2018. So it's not quite on point. I mean, I didn't expect Fuchsia to ship on time, and people should know that. But yeah, let's hope that's actually going to be the time when they get them out, and that's during Murph. So
yeah,
nice timing.
Perfect. I'm also really excited that they finally said that they have their PI covered.
They're coated beds.
They're coated beds. Yeah. The process dialed in, and they're gonna start mass production after a couple of trial runs. Because I don't have one of these powder coated beds, and I just really like, I would love to have one with a texture on it. But
I can see if I have a spare. I think I do.
but you can't currently get them if you just buy the upgrade kit. You always get the just the normal one with the PEI sheet, which works great. But I kind of really like this textured surface. Some people don't really like that, but yeah, I'm fine with that. It gives like a more uniform look of the part.
Yeah, that was one of my big points with the Mark III when I originally reviewed it. Man, that is an old printer now. It's like it's over a year old.
Yeah.
Yeah, it's just the bottom surface is not this alien surface that is like perfectly smooth or glossy, and the rest of the print has a texture to it. Yeah, originally they did ship me like 2 different versions, one that is mostly smooth and one that has that classic characteristic texture to it. And the mostly smooth one still has a bit of that unevenness simply because it's a powder coating process. It's never going to be perfect, at least not with the way they, I guess, apply and bake it then. So yeah.
Looking forward to hopefully sometime I'll be able to order one of the powder coated bats as a, well, after purchase.
Yeah, I'll try to get one to you because I think I have a spare somewhere.
Perfect. Yeah, on other news.
We have a big news section
today.
We
have a really big news section today, so that's probably covered most of the podcast. The Nozzle X drama, E3D's new, not zinc-coated, nickel-plated,
nickel super alloy,
high-temperature nozzle. Yeah. Could you maybe explain what happened there? And
okay, what is the Nozzle X? Let's start at the beginning. So E3D have always had, well, always, but for the longest time, they've had their standard brass nozzles, they've had copper nozzles, and they've always had hardened steel nozzles. And I guess one of the issues they had with the hardened steel ones was, first of all, it's a raw surface. It's kind of a blackened, bruniert. It's a chemically etched, I guess, surface that they come with. And also the alloy, the steel alloy that they were using for it, if you were using it at extreme temperatures with the copper blocks and all, would soften over time, so carbon would start to dig into it, which is like the main point why you even use a hardened steel nozzle. So they announced or engineered the Nozzle X, which is a new alloy. And it also comes with a nickel super alloy, super hard coating, which is, I guess, how is it sputtered on? Is it chemically?
I guess it's chemically put on there, and it's supposedly really unsticky, so it's good for sticky materials, starting from the edge PETG material.
Well, that, and also just by laying down filament, it's not going to drag the filament back up as the nozzle slides over it. So, all good. That thing was released, was shipped. And a few days later, we saw from Your Daily Micron on Twitter a few photos. I don't know if it were her photos originally, but we saw photos crop up where apparently, or it very much looks like the nozzle was not drilled properly. Or somehow, the hole, the orifice ended up not round. And some of the photos look pretty horrible. So, yeah, you look at those, it's like, wow, how do you even manufacture something like that? It's crazy. So that got a bit of traction, and I think it was zoomed in cell phone photos with classic lighting from one side. So I think what happened is because the bore is never perfectly, sharp with the edges, especially with the coating, I think you just get some shadow and it doesn't look, you get some shadow, some reflections, and it doesn't look round. Your phone camera starts doing some processing on it, and well, so E3D published a blog post, put it on there. Who's making that microscope of theirs?
Keyence.
Yeah, so they have like a Keyence inspection microscope that digitally measures out your dimensions, and they posted photos of that. It's like their production inspection tool as well, where they sample some of their production run. And they were like, well, guys, it's round. It's it's very well within tolerance. And yeah, to me that was the end of the story. you take good equipment, you measure it, versus you take your phone camera and you look at something and it doesn't look good. Well, but your Daily Micron kept pushing back, and it was like, good equipment used improperly still gives you, bad results, and so the promise by your Daily Micron was, okay, I'm gonna get these nozzles to someone with a good microscope, and we're gonna investigate those, and we're gonna look into those, and that was the end of the story. So far, nothing has happened on that front, and that was almost a month ago, or at least over 20 days ago now. So yeah, apparently I'm a troll because I'm asking about how that is going, and I'm being mean here. But yeah, it's a pretty one-sided discussion, because one side is actually looking into things, and the other so far has only made some claims and some cell phone photos.
Yeah, it's nice that E3D are handling this thing that openly. They usually take their QC serious. They're also saying that they just can't be 100% perfect, but from everything they have done so far, the first batches seem to be fine. And they have also been posting a couple of pictures where, if you take a look at the orifice from the wrong angle, the nozzle, or the hole, just looks a little bit like teardrop shaped.
Yeah, I mean, I'm not saying that E3D is like infallible and they're perfect and they can just get everything right from the start. And people have been quoting the Titan extruder bearing story about this. And yes, they've shipped products that weren't perfect.
Yeah.
And that was, I think that the bearing was not properly sized and was under too much tension or something. They do screw up. Everyone screws up every once in a while. But so far, I don't see any like solid evidence that the Nozzle X is a screw up. Yeah, I think we should rely on actual evidence more before we go out and shout, this is bad.
Yeah. Do you actually have a Nozzle X?
Do we have a Nozzle X? I don't think I have one.
What are you usually using in your Prusa printers? Are you using the standard brass nozzle, or are you going with the hard steel ones?
So I do have most of my machines on the standard brass nozzles. I do have one Mark II that has just a standard hardened steel nozzle in it. And in my experience, it prints almost identically to the brass nozzle, to the point where you can use the same settings, and if you don't make any changes to your slicing and profile and temperature, you can get away and get a good print out of it. But yeah, I don't print carbon fiber filaments that much, simply because I don't see the massive difference that it would imply by having that massive price difference.
Yeah, I get you. Yeah, because I'm also, always using a hardened steel nozzle in my Prusa, just because I sometimes use abrasive filaments. I also already experienced the problem that I had been using a brass nozzle before, and even though a filament supposedly shouldn't have been abrasive, the nozzle looked kind of bad after a couple of prints.
Yeah. How did you inspect those nozzles? How did you clean them up? I think that's the better question.
Well, sometimes I'm just using cleaning filament. In my experience, that works kind of well. It's not really necessary for the easily removable ones, but if you have an Ultimaker where you just can't really screw out the nozzle easily and clean it out,
or just buy a new print core, right?
Yeah, it's just $120. It's a good system, but they're and you can't actually get replacement nozzles for the Ultimaker. That's horrible. You have to buy it totally.
Yeah, you just buy it. You just buy a new print core. Like, why would you want to replace the nozzle? Come on.
Otherwise, so sometimes with the brass nozzle, I just screw it out and then take a torch and torch it. But I have also already been ruining some brass nozzles with that if they just get too warm and then they start melting. Yeah. But usually I just use a brass brush and I clean the nozzle after every couple of prints when there are some residues on the nozzle. And I'm a huge fan of cold pulls.
Oh yeah,
That's usually
cold pulls on both sides, like the inside, and you can actually smush some nylon filament onto the bottom of your nozzle and encase it, and then as the nozzle is heating up, just pull it off as one chunk. That's so satisfying.
Oddly satisfying, yeah.
Yeah.
Yeah. So usually when I change my filaments in my printer, I do cold pulls just when the nozzle reaches like 60 to 70 degrees, and that already gives me a nice indication if I have a moisture problem, because you can already see if the thing you have pulled out has lots of bubbles in there, which I really like. And also you can see the internal shape of the nozzle, and even the you can measure the diameter of the nozzle itself.
Right, yeah.
Which also works kind of well. And I always take a look at that. And I also find it oddly satisfying just to see this perfect negative shape of the internal surface of the nozzle.
Yeah. I've had cases where I was printing PVA, especially in multiplexer setups. And you can see with the cold pull, you might get the nozzle bore itself, but then that bevel or that end where the drill bit goes in just stops being sharp, and it starts getting rounded over, and you can even see the restriction where you start getting that thinner and thinner and longer channel where just the black soot starts caking up the inside of your nozzle.
Yeah, PVA is horrible if it just is too hot for too long. If it's too hot for too long, then it really gets this sandy grain structure.
Yeah, it's not fun to print with unless you've got it perfectly figured out. But again, the multiplexer setup. We've actually gotten a comment on YouTube going like, hey, I like my MMU2 with PVA and PLA. I've not gotten multiplexers to work that well yet, but apparently it's possible with the perfect settings. Should we keep going with E3D?
Yeah,
because they have not only been defending themselves with the Nozzle X, but they now also need to defend themselves with Pathio. So it's Pathio. Just to rectify that, I think I wasn't very clear in the video. Pathio is an independent company of E3D. They share the same building. They share the same coffee maker, but they are like legally their own entity. So it is the Pathio companies, E3D, Skunkworks, whatever they're called now, and they're making a slicer. They're making Pathio, and last podcast we were kind of giggling about it. That's not really too much because I mean I've signed an NDA with this. I've seen it last September when he got October when I got the tour of E3D, and I had to blur out some whiteboards and some stuff. But yeah, Stefan, you've been trying Pathio out as well, right?
Yes. So I got my version of Pathio just at the end of last week, so a couple of days before the real release, and played around with it over the weekend.
It's not just you.
So I know that they have been working on that software for the last 18 months or something like that, with
18 months is the official
almost
time frame.
10 people there. The graphical user interface looks nice. The workflows are great, but feature-wise, it is just at the moment not comparable to any of the usual slicers you use. So at the moment, I don't feel that I have a real benefit using Pathio. So that was the reason why I was a bit disappointed. I was hoping that for their first release, they already have one of their key features implemented already. And I also tried out, for example, the support structure with the teeth, so the three-dimensional support structure. And supposedly in the version at least I am having, it is not activatable. I don't know if you have already been trying it.
No, so I've not updated Pathio since I made that video. I think I should, but the very first version that I got had supports just completely broken. I think you could make some more choices than the current version or the last version I tried. But the version that, when the video came out earlier this week, that was the version that just has those zigzag support settings or what's it called? Needle
support thing.
Yeah.
Which
This
as Sanjay told me, should work really well if you have them tuned in. And I was really hoping that they have one of these features already implemented in the first version, because that would make it then it would be worth spending the time on the slicer if it has a feature that none of the other current slicers really have. It works, it slices, but it's just not. It's far from the results you get from Cura or Slick 3R or whatever.
Yeah, I feel like that there's two ways that they can go. Is the first one, and kind of the boring one, but that's probably the one that people are going to want, is, hey, please implement this feature I've seen from this other slicer. Please do this, do that, do that. So you get feature parity with everything that's out there. So you kind of have this big mishmash out of all the existing slicers and take like, this one does that well, so let's use this here. That is the kind of boring way they could go. And they've not achieved that, because I mean it's still missing so much stuff that isn't even just comfort features and premium features, but it's just usability. The slicer right now is not something that I would use productively. The other route they could go is to say, okay, we're going to have like these 2 or 3 features that only we have that are really unique to our experience, and all the other stuff, well, we'll get to that eventually, but here's a reason to use this slicer right now, because no other software can do this. And I think that's the more exciting and the more engaging version of it.
I think that's the only way how they can achieve their goals, since it's not an open source software. They want to have it will be there will be a paid version later on when they are at this, possibly. And in order to get people to pay for their software, they need to have outstanding features none of the other slicers have, just like Simplify 3D used to have their custom support structure.
Yep. Well, it still has it.
It still has it, but they are not anymore the only ones that do have that feature. And if they are not managing to accomplish that in the future, it's going to be hard for them, but they are on a good way. I just think they released it a little bit too early, because I don't know how many really even downloaded and tried it out. But as I just said, at the moment, there is no real reason to use the slicer, as hard as that sounds.
Yeah. Exactly my conclusion as well. I think they were trying to catch that moment where Simplify 3D was getting a lot of flack for paid upgrades, and the version 4.1 or 4.0 or whichever one isn't working well for a lot of people, and they're getting crashes and they're getting issues with profile downloads. And of course, if you come in and say, hey, we've got this new thing now, of course that's going to attract a lot of attention. So I think. So, I mean, I've been thinking about it. I've criticized them a lot on, not being a fully featured slice and releasing so early as well, because I, just like you, I've been disappointed with the release. But here's the thing. This is a beta release. And as with anything else that is beta or pre-release, or, Kickstarter writing you up going, hey, would you like to try out my product? I'm launching this Kickstarter in a week. Would you like to promote it, please? It's like none of the stuff that we criticize right now matters until it's actually a product, until it's actually shipping.
Yeah.
So because E3D are not charging money for this yet, because it's free right now, it's like, okay, whatever. If it's no good, then use something else. But you're not getting anything that you've paid for. And by the time it releases, it's probably going to be a vastly different product. And whatever I say about it right now is not going to matter anymore, because it's a different thing.
They laid a really good foundation for that. They built everything from the ground up. They have an internal structure which might make it possible to do some pretty interesting things other slicers just can't do, because they work internally differently. The GUI is nice, the ideas they have in there, the ideas they have in the direction of sharing profiles for printers and filaments is something which is pretty nice in my opinion. They are aiming towards the more professional market with their scripting features and all of the things like that. And they will be and they hopefully will be implementing outstanding features like, for example, this three-dimensional needle support structure, which might be a thing in the future where you say, okay, I will buy that piece of software because that really helps me to get better print quality out of it.
Yeah.
I still hope that people are currently downloading software, taking a look at that, and then just give a little bit of feedback, constructive feedback, and tell, okay, this is not working for me, or could you maybe go a little bit more in that direction? And this is, I think, also what E3D is aiming for, to get feedback from the community and see if they're heading towards the right direction. Because otherwise, they could have been working like another year on that software, release like a really kind of finished product. But if it is not what the market is looking for, all of the effort is just worthless.
Yeah, if you just work in a vacuum and you're like, oh yeah, we've made this really great thing, and it comes out and people are like, oh well, this isn't quite what I expected. It's interesting. It's like, yeah. Again, I'm hoping it's not. I'm hoping that they are going to focus on those unique selling point, those USPs, instead of just going for feature parity with everything else, because that would be boring. And we have slices that do feature parity already. But yeah, we'll see. We'll see where it goes.
Yeah.
Still right now.
I guess we are heading to the last point in our news feed, and that is some things about a 3D printer manufacturer. I haven't been hearing anything from until like a couple of weeks ago, and that's Artillery 3D, where again they are using or promoting their printer with pictures of prints that haven't, they're not giving credit to the makers of the initial model, and they actually haven't even printed on their own machine, because these pictures come from a guy named FilamentFrenzy.
Yeah, Tom Jackson.
On
great guy.
Yeah, on Twitter. And selling his photos that have not been printed on that machine as prints you can make with their printer. And that is kind of bad.
It's like, it's not just that it's false advertising, right? Because it's prints that aren't made on the machines, being advertised as prints that come from that machine. It's also disrespectful. It's just a smack in the face. You take someone's photos that they've spent time on, photographed it well, tuned the profiles. I mean, FilamentFrenzy, Tom is known for having simplified 3D profiles for so many printers, and tuning those in really well. And that's been his work. He's worked hard to get that print perfect. And then Artillery 3D comes in and says, "Hey, look at what we made." That is, I don't know, man. I don't know. And apparently they've also been pretty aggressive with sending out emails and, hey, please review our machines to, I think, Joel, and definitely to Angus, where he had to block their email address. They've sent a few emails to me as well. I've had Niels deal with them. Don't want to be bothered. And yeah, I don't know. Supposedly, well, I mean, you never know with these companies, right? They're kind of like cookie cutter companies from somewhere in the Asian region, whether that's China, Hong Kong, Taiwan, maybe. Not Taiwan, not so much. But somewhere in that area, it's, hey, we're taking these parts, we're putting it into a frame. And if you look at the Artillery 3D printer, it looks pretty unimpressive. And it's just like, hey, here's a brand name. Let's promote it. Maybe some people buy it. It could be anyone. Artillery 3D is not the only company that does this, to be frank.
Nope.
Yeah.
There are the photoshopped printer images where they just photoshopped any part on the build platform of the printers. There are other companies that advertise their printers with models where they don't really give credit to the creator of the models. And there are even ones that steal pictures from prints that haven't been printed on their machines and sell them for their own.
Yeah. Just horrible business practice. So Artillery 3D, I was almost going to say something rude here, but you can read my Twitter if you want to know what I think about them. I'm not going to be reviewing their printers, and I'm not going to recommend anyone to buy their printers because, well, false advertising and completely disrespectful against the community. That's just two things that are absolute no-goes, I think.
Definitely.
Cool. Do you want to talk about Article 13 at all? Do you have the energy to take on that?
Well,
that shit show?
Well, you just started. Maybe just talk about that for a couple of minutes and then go to the more interesting things.
God. Okay. Article 13, European copyright reform. Copyright reform is well overdue in our regions here. The US has something like fair use, which is fantastic, I think. We don't. Anyways, doesn't have anything to do with that. European Union has just moved forward on a copyright reform that would require any platform that users are able to upload content to make sure that content is not infringing on copyright, on copyright that isn't licensed to them. And the amount of incompetence that some of the politicians involved in this have demonstrated is just horrible. I mean, Axel Voss, that's like the guy who's rightfully so been getting the flag for this. He doesn't seem to have an understanding of what he's even promoting here, what he's pushing into law. So basically, what Article 13 or that entire copyright reform would require platforms, as in someone who runs a forum like me, or pages like Thingiverse or Imagine, etc., unless they're like under a certain revenue or are less than 3 years old. And 3 years is just, oh yeah, cool, I've got the domain now. So basically anyone it would affect. So they need to make sure, or first of all, the big thing is, so far if a user uploaded something copyrighted, like a pirated movie or something, the platform would be okay. It would be the user that can be prosecuted for this. Now the platform is fully accountable for the content the users upload, and they also need to implement some sort of a system that will need to scan every piece of material that is uploaded before it goes online. And that is just something that is not viable. It's not technically possible. Look at YouTube Content ID and how well that is working. So yeah, right now that Article 13. Well, the legislation that contains that Article 13, which is the kind of the critical one, and Article 11 and a few other ones as well, has not been put into law yet. It's what it's going to be, a EU directive or whatever that then the countries have to sign into law. But if it goes through, I will probably need to take the forum offline, and we're going to have to see what happens to pages like Thingiverse, etc. The legislation is written to go after Facebook or YouTube or those big platforms where somebody might upload a copyrighted cooking recipe. Who knows? Bad things, right? But effectively, it's going to hurt the smaller companies because they don't have a way or a means of implementing those filters that it's saying, oh no, we're not requiring you to use filters. Actually, filters are like the only way to fulfill these requirements. So yeah, it's going to hurt the smaller platforms, and the larger ones like Facebook are just going to go like, whatever, come get me. Like, yeah.
So they have not yet voted on that Article 13?
Yeah, so it's not just Article 13. So the thing is, it's the actual text of the legislation is kind of finished and is going to go up to vote. What is it, the EU Rat or EU? Some final organ within the European Union is going to have to sign that into law, and it's going to have to actually, move it forward. So far, it's just that the actual text is done. If you guys care about the free internet, all of you listening or watching, there are ways of telling your politicians, the folks that you support that are in the European Parliament, whatever that the next step there is, you can send them an email. Not everyone is a bot, and that's actually one of the arguments that Axel Voss has been making when he got thousands of emails from people going like, "Hey, dude, what the are you doing?" He was like, "Yeah, all those came from Gmail accounts. Like, Google is just sending bots after me here." Yeah, yeah. Just screams for competence. Now, for the record, I'm the European Union. Fantastic thing, fantastic organization. Sometimes they screw up. They're people, after all, and this is kind of a screw up that is going to affect us as creators, because who knows what YouTube is going to have to do, or other publishing platforms, and it's also going to make the internet a less free place for all of you. So it's in your interest. The only ones who will be profiting from this is like big media, the big movie companies or whatever. And like small creators like us just have a ton of extra work, a ton of legal risk when publishing things, and or providing platforms like a forum, and don't really have anything to gain from this. So from our perspective, it's not really a great legislation that's going to come our way.
Yeah, I totally understand you. Should we head on from that sad topic?
Yeah. Cool. Let's move on to something productive.
So I have suggested for the topic of the week that we will be talking just a little bit about 3D scanners. So 3D printing is something we usually talk about a lot, but we both have already been working with 3D scanners on our own. You have a
Einscan something.
Which is a structured light 3D scanner?
Yes. So the way it works is it has like it looks like a Kinect head, and it has a small LED projector that projects like varying light patterns. And then offset from that, it has a camera that picks up those patterns and looks where those patterns are actually shifted left, right, up, down, from, because it's looking at perspective. So that is structured light, and that works with any surface that is non-reflective, basically, and not black, or not. What's the word? It's not glossy. There's a word that describes this. How glossy is whatever. So any matte non-black surface.
So yeah, I have been working with photogrammetry a bit, and this is also this is a technique where you take a couple of pictures of the part you want to scan in, and then a software calculates your 3D object. It at first calculates the position where the camera was in space, where you like went around your object. And if you have an object which has structures, so where you don't have just a uniform color or something like that, it also gives really, really nice results. And it can be done with a smartphone. There are a couple of smartphone apps that can be used for that. You can take your good DSLR and go around objects and get pretty detailed scans out of it. The only thing that is problematic with that technique is that, as I said, the parts need to have some structure on them. So there's
some texture. Right?
That's the right term, because otherwise the algorithm doesn't work. And it is not to scale at the beginning. So you get an arbitrarily sized part out of it that you need to scale with some reference measurements. But it's also working pretty well, and there are lots of open source software tools in order to convert the pictures into 3D models, and also a couple of other commercial software packages like Sapphire 3D, which I have been using for quite a bit, which is a really nice software package.
There's and the thing is, it scales. I mean, the models are not to scale, but it's a very scalable process. Where the structured light one that I have it has a little turntable, and you can use it without that and just move the scanner around, and it's limited to like I think 70 centimeter box or something.
And that's already
photogrammetry.
And that's already pretty big with a 70 centimeter box.
Yeah, I think that the premium model goes a bit bigger, but
Yeah.
whatever. Photogrammetry is used at any scale. They literally have drones flying through the Alps and mapping out entire mountain ranges, basically. So you have
If you have ever been in Google Maps in one of the larger cities, the 3D maps they have in Google Maps are all done using photogrammetry. So they had planes flying over these places, and with the photos that were captured from different angles, they can calculate really, really detailed models of the Earth and the cars and the trees and everything which is there. It's unbelievable.
Was that actually planes, or was that from satellite photos?
I'm not sure. I would assume these were plane images, because you need some kind of inclination angle that works out, but I could be wrong there.
Right.
I would bet on airplanes, but I'm not sure.
Okay, but same process. You take your 2D photo, which has no depth or positional information. Well, I guess with a plane or with drones, you have that GPS as a rough reference, but you don't need that. And then the software, learns.
Matches pictures.
Learns is the wrong word. Yeah, it matches where the photo was taken from, and then looks again at textures and matches textures to each other, and by perspective again, makes out where those details are. And yeah, again, same thing. It works on perspective. You just take a ton of photos from the same angle, from the same perspective, you don't get any 3D effect. So you actually need to move around your object. So if we were to scan something like regular sized palm sized thing, you'd use 20 to 50 photos maybe, and you end up with a scan that has the original texture, so an actual colored scan, and is dimensionally usually okay. There are some artifacts when you have like glossy bits and reflective things, and areas that have no texture, but overall gives you pretty good results.
Definitely. And the last technique that is commonly used for 3D scanning is laser. Did you find something?
There's a hair in my lens.
The last technique that is commonly used for 3D scanning is a laser scanner. So I have a very low grade Cyclop 3D scanner, which used to be I think a Kickstarter a couple of years ago, where you basically project a laser line on your object and capture the laser line or the distorted laser line with a camera, and using triangulation, you can then recalculate your 3D object. It's kind of a way similar to structured light scanning, because if you're using structured light scanning, you basically just project like tenth or hundreds
laser lines,
hundreds of lines on your object, so it's faster. But the thing is, with the laser you are usually using, you can also work with parts where the illumination is not that critical, and you are more flexible. So you can also get these 3D scanners in a handheld format. So you can like take them around your car and scan your car in if it's not reflective, and if you have a matte finish on your car, or bigger objects. So structured light scanning is usually only used for smaller objects, because you have a stationary setup. These laser line scanners are usually or can also be used for bigger objects, are a little bit more flexible. As I said, I have one of these Cyclops scanners. I also did a live stream, I think it was more than a year ago, and I have been playing around with it for ages, but never really got it to work properly, which is unfortunately.
So the Cyclop, that's a BQ. BQ?
Yeah, it's BQ, right? Actually.
Yeah. So not sure if that was Kickstarter, but that is a fully open source scanner, and you can build those with basically they use just a cheap webcam and a line laser and a turntable. That's like the base premise for them, right? Yep. You have your setup. You have one laser that is offset from the camera, just with the structured light, as with the structured light. And you have a turntable that turns, and by where the line is offset, you scan. Same with me. I've not gotten those to work particularly well. Um, the yeah, the thing is, it's also limited by perspective. So if you have, well, I guess because this thing is in range, if you have like this handle, which is of course fantastic for audio listeners, but anything that is occluded from sight, where the laser can't reach in, but the camera still sees it, is not going to get scanned. I don't know if that makes a whole lot of sense. But for example, if you have a cup and lay the cup sideways, one side of that cup is not going to get scanned because the laser can't reach in there while the camera still picks it up.
Well, you can use multiple scans and then merge them
True.
together.
But it's always going to be it's always going to be a pain to match those up. It's kind of the same thing with the structured light with the Einscan. You can also merge multiple scans together. Whereas with photogrammetry, that's just the nature of the game. You always have all your photos as one scan. It's all getting merged. Yeah, you can't really reach into like deep cavities with structured light or laser line scanning. Now, as far as like detail reproduction goes, those three approaches have like a pretty wide range and pretty stark differences between each other. Where, with the Einscan, I've been getting incredible detail out of the scans. Even though I only have the lower end model, and the better one supposedly has like twice the details, it's still like you get every little speck. Like this table has just a natural wood structure that would get picked up. The mesh of this microphone, which has like 0.5 or 0.4 millimeter holes, those would get picked up. Maybe not as holes, but as texture. So structured light with the Einscan, fantastic reproduction. On the other hand, the Cyclop or laser line scanners, maybe it's because the webcams we're using aren't that fantastic.
Well, yeah, the resolution of your scans is dependent on the camera system you're using.
Yeah.
You can't really get more details than the pixel of your camera is delivering you, even though some of the scanners use sub-pixel accuracy, but still there is a physical limit. But yeah, depending on the scanner you're using, the objects and the details you can scan vary, but it kind of depends on the setup you're using. So you can get incredible details with photogrammetry if you have a macro lens and you really take pictures from very close up. But you can have it the totally different way, as you see in Google Maps. You can scan whole cities with that, and just the resolution is not that good, but you don't need it.
Yeah. So the thing with the software that's being used with these tools, BQ has their own software that is being used with the Cyclop. That does the processing on your computer. It's not that intense. The Einscan also has a software that comes with it, which is a proprietary piece of software, which uses a lot of resources and actually demands an NVIDIA chip to use CUDA with it. Otherwise, it's going to be dead slow. And even if you have a good NVIDIA graphics card, it's still pretty slow because it's a ton of points that it's kind of mashing together. With photogrammetry, you get a bit of a wider choice of software solutions. Some that run locally, some that run in the cloud, which is just somebody else's computer. But what's your favorite photogrammetry software right now?
As I said, I am using Sapphire 3D. I think it's called Sapphire 3D. It's an Italian company. They have a free version where you can load in Steam, which allows you to use it's 150 or even 500 images, and then there's a really professional version where you have unlimited capabilities, or only your PC kind of limits the amount of pictures you can use. It is working really well. I have also tried the open source tools. There are some two really good videos on the Prusa 3D YouTube channel where they did two scanning projects there and show how you can use the open source tools to convert the images to 3D models. But there are still plenty of other software, plenty of other tools around. Also, Autodesk used to have a really good one, which is not available anymore.
They used to have Catch, which was the original 123D software, which was horrible. When it worked great. But well, they canceled it. It's not available anymore.
Yeah.
But it was like, okay, because you had to upload all the files, and the upload process, the processing was just super buggy. Not that I would expect anything else out of Autodesk, but yeah, then they had Recap, which is like the more professional version, but also had like a free version, which worked a lot better, but I think still used the same engine. And I think that is still around, but don't quote me on that.
Yeah. But, application for 3D scanners. So you have been releasing a video where you scanned a part of your, was it compost pile?
Compost bin pile,
So
thing that you cannot buy, you scan it, you reprint it, and it's still working to this day. I mean, the rest of the plastic compost bin is falling apart, but at least that part that I printed is holding up.
So this is reverse engineering. So you can use 3D scanners to reverse engineer, or in the most simple case, just scan the part. You get an STL from the scanning process, make it watertight in the end, and directly print it out again.
Yeah. And just a quick note on that, people have been discussing, hey, is that actually, from a copyright perspective, is that actually legal? But the thing is, copyright applies to art, and a mechanical part is not art. So you can copy those and do whatever you want with them, basically. Unless, of course, you're infringing on patents. That's a different story. But copyright, no problem.
Yeah. You can even go a step further, scan in the STL file and then load it into a CAD package and do really reverse engineering in the CAD software, that you get a proper CAD part out of it. That's how many others are using it. If you, I used to know a guy who had a professional reverse engineering business, and they always bought the latest cars, took it apart completely, scanned in everything, and then sold that. Well, these results to other companies.
No.
I don't know where they came from, but yeah, you can make up your mind about that on your own.
Interesting approach, huh?
Yeah, but this is also something you can use. Use it for 3D scanning is used, for example, at your dentist. If you have a real professional young dentist, they don't sometimes they don't use casts anymore of your teeth. They directly 3D scan them and then do all of the things if you need a new tooth or brackets in the PC. That's also something you can do with it. It's not something which probably everyone is doing, but it's also something you could do. And then one thing where I use 3D scanning a lot at work, at least, is metrology. So, we do 3D scanning to check the dimensions of our 3D printed metal parts at work. So, you have a CAD model, and many assume that the CAD model you print out is then perfectly your 3D printed part. But just due to inaccuracies during the printing process, and especially warping or deformation due to thermal stresses and things like that, your parts can get quite crooked in the end. And 3D scanning just, scans the whole surface. Then you do a comparison to your CAD part, and you know how bad your part is, or even use this information to pre-deform your part, so you kind of have a crooked STL in the beginning. You print it out, and then it is just like you want it to be. That's also a pretty interesting application.
Yeah, and that's actually something that is being used pretty much everywhere. I know from sheet metal processing, you have entire tool sets and entire software packages that do like the back spring or spring back from your sheet metal stamps, and that simulate that, and then you go in with your scanner and scan the thing, and you feed that back into the software, and it adjusts for how much it actually deformed from where you thought it would go. That's something that is very real in the industrial world right now, and very useful. But I mean, for makers, people that are actually listening to this podcast, I think, by the way, let us know in the comments, why are you listening? Are you a maker, or are you using this stuff for your job? Where can they use 3D scanning. I think so. So I think the first thing we kind of need to establish is that the models you get out of a 3D scanner are not something that you can really well, they're not the same as if you would have constructed it in, say, Fusion 360 from scratch.
Yeah.
Unless you have a software package that actually converts your mesh or your point cloud, that's actually what you're getting, back into a parametric solid. There's some packages that do that somewhat automatically.
Yeah.
But they're not something that you're going to be using as a maker typically. Doesn't Fusion? I think Fusion has something like that.
Fusion has the sculpt tool. It does well. Yeah, it can actually convert an STL file, which you basically get after the point cloud reconstruction, into a real solid part, but it is just don't use it.
Okay. Yeah. Don't use it. That's a good tip. So basically, you get this kind of messy, non-perfect STL out of it. So I mean, what you can definitely do is, like you mentioned, you can measure it. You can take it into Netfab or a CAD package and just measure how big is this hole, how large is this feature. If you have something that is to scale, if you're using a structured light scanner or you had a size reference in your scan. You can also, for example, with phone cases, you can also take your phone scan, or the scan of a phone, and take it into a CAD package and construct around that, and just work off of those surfaces. Maybe not reference them, but actually, line stuff up and make sure it fits, and then tweak it after first print.
Yeah.
I don't know how else would you be using this practically.
Well, if you're a designer, you can 3D scan your designs and share your designs online. That's something.
And that's actually how a lot of the movie visual effects, whatever, is being done, where you have a sculpted part that is hand sculpted, and then it's being scanned and reprinted at a larger scale or with a few details, or just reproduced if you want more than one part, if you don't want to cast it from a resin. Yeah.
You already said like a reference for like reconstructing something, using it as a blueprint. I don't know.
Mesh mixer? Mashing up two physical parts, because I mean that's what Mesh Mixer is really great at, where you have one scanned object, and for example you have your bunny and you want to put a golem head on it and mash those up. That's something that you could do physically. You could just mash the head over one of them and hot glue it on, but you can also do it digitally. Yeah, it's interesting because it's kind of like SLA printers. It's this technology that we have, but we still have to really figure out how to best use it. And as software catches on, applications catch on. But I mean, the good thing is, especially photogrammetry, everyone has the tools to use this. There are free software packages or cloud services out there that you can just upload your stuff to. Any phone camera is good enough, as long as you move around the object and don't move the object itself. But that's kind of the basic photogrammetry rule set there, I guess. And yeah, you can just try it out.
Play
it's
around
free.
with it. Yeah.
It's an afternoon that you can spend on it, and you can get some really great results from it if you know how to make use of it.
Yeah, definitely. Cool. So yeah, as you just said, it's not something for everyone, but it has its applications, and I sometimes find it like really satisfying just to see, even from a photogrammetry scan, to get the digital representation of the scanned part out of it.
Yeah. I mean, you do get the texture with the photogrammetry scan, and that can sometimes be a bit misleading because it looks like a more detailed model than it actually is. And if you 3D printed, you of course don't get any color unless you're using a full color, but you're probably not going to do that. But yeah, still, it's a very, very useful technique for the right applications.
Perfect. Yeah, I think that concludes it for our topic of the week.
Absolutely. Should we ask her? I can never get that right. Should we ask her? Should we answer one last quick question?
Yes, go ahead for it. And we are not 100% sure if we have already been talking about that in the last podcast. But yeah, if you have questions, send them in. We try to answer them. Just leave them under the video on YouTube.
Yeah, Grogian. That a why? Yes. Grogian is asking on YouTube, have you tried to print directly onto copper-clad board with a normal plastic extruder, so your normal 3D printed tool with, say, a 0.25 millimeter nozzle. Stefan, have you tried that?
I haven't been trying it so far. No, we have been talking about that last time in together with the PCBs, or with the PCBs. No, I haven't been trying it. I think we concluded that just using a marker pen is more simple than getting the plastic to stick on your copper clad.
Yeah, and I mean that's exactly what I'm going to do. The issue I see with getting plastic to stick on copper clad is, first of all, you need a material that actually sticks to copper. Copper does oxidize fairly quickly, and not everything sticks to it unless it's like super preheated. Maybe with a flexible filament that sticks pretty well. Maybe with a PETG that is super sticky. But I'm doubtful that your normal materials will actually bond to a copper. And then also they need to bond well enough so that your etching solution doesn't creep underneath your 3D printed part and etch away things that weren't perfectly covered, because that's the entire reason why you would print onto a copper clad, is to create an etch resist, basically, that keeps the acid, the etching solution away from the parts that you want to keep. And that just needs to be perfectly smooshed down onto your copper and make a really good seal.
And it's way harder to just check in comparison to other if you're using a pen or other etch resist techniques, because you can never be sure if all the material is sticking well at each place.
Yeah. All right. Fantastic episode. As always, if you guys have any questions, leave them in the YouTube comments below. We read each and every one of them, or tweet at us at the Meltzone. Stefan, thank you for your time.
Thank you for your time. Listeners, thank you for your time, and viewers. And we see you guys around in the next one.
All right. Bye-bye.
Bye-bye. Cheers.